Hi everyone, welcome back. Okay, let's look at this for each loop with an additional statement inside of the body. When we look at every item, it doesn't mean that we have to do the same thing to every item in the list. So it is possible to do selective processing in a for each loop. So in this case, we have a for each loop, and the body of the for each loop contains an if statement, and that if statement can then make some decisions about whether or not it should do anything with the item from the collection that it's currently inspecting. So here we have a method named findFiles, and what it's going to do is it's not returning the files to the caller, it's void. It's just going to print the files out. So this would be like a search result, for instance. So let's go ahead and search for all files inside of the project that have some pattern inside of the file name. So we can pass that in to the method as a parameter. Then we can write a for each loop for every file name inside of files. Okay, grab the first file name. Let's run the contains method on a string. Remember, a string's an object. So if the file name contains the sequence of characters that it was passed in the search string, then we'll print it out. If it doesn't, we skip over the if statement. There is no else, so we're out of the if. We get to the closing curly brace for the for. We come back up. We ask the files collection, do you have any more items? You do. File name now has a new value. We come back in. We ask the question again, does this file name contain the search string? It does. Okay, we print it out. We're at the end of the if. We're at the end of the for. We come back up. Eventually, we get through all of the files, all of the strings in the files collection. And so we drop out of the for each loop, we drop out of the findFiles method, and our task is completed. So just keep in mind that we can string these things together, we can snap these pieces together, whether it's a decision-making process, like an if statement, which decides and continues to move forward, or if it's a looping statement, like a for each. And we can put these in places to generate the algorithm that will solve the problem we're trying to solve. Okay, let's look at our for each loop again. Advantages of the for each loop. Once you get used to the syntax, very easy to write. Second, it's always going to end. Does not have the possibility of an infinite loop. These are good things. Now, something that's really important to keep in mind with a for each loop. We're not allowed to change the collection. If we change the collection, the for each loop becomes invalid. It's no longer guaranteed to look at every item, and that becomes problematic. So if we need to do deletes, the for each loop is not the right choice. With the for each loop, there is no index provided. And that's a benefit, actually, because not every collection has an index. There's no native way to stop with a for each loop. The purpose of the for each loop is to process every item. Now, inside of an if statement, we could choose to use the break statement, which will break us out of a block, but there's no way for a for each loop in its normal structure, in its command structure, in its syntax, to say, oh, we found something, we can leave now. So these are kind of the considerations that you should be thinking over when you're writing your own code to say, is a for each loop a good choice for what I'm trying to do? Since we've talked about definite iteration, something that is going to stop because it's going to process every piece of information, it's time to talk about the idea of indefinite iteration. Maybe we will process everything, maybe we won't process everything. If we write it improperly, maybe we'll never end. And this indefinite iteration can be handled using the while loop. So let's take a closer look at the distinction between definite and indefinite or unbounded iteration. And also, let's look at the syntax and the basic structure of the while loop. A very common thing to do is to search for an item. So unlike the previous search, which was tell me everything that meets this parameter inside of the entire collection, here we're looking for something and maybe it doesn't exist in the loop, or maybe it does exist, or it does not. Maybe it doesn't exist in the collection, or maybe it's the very first item we'll look at in the collection. We don't know how long it's going to take. So let's move away from the computer concepts and just think about searches that you do in real life. If you're like me, every now and then you misplace your keys. You don't know ahead of time how many places you're going to need to look until you actually find the thing that you're looking for. Now, there might be a limit. It's like, okay, I give up. I will go and contact my dealership and get a new car key for this vehicle. But generally speaking, you're going to look and you're going to keep looking, and when you find them, you don't need to look anymore. So you stop when you find them. Which leads to the aphorism, you always find something in the last place you look. The implication being, once you found it, why would you keep looking? Because I'm a cantankerous sort, every now and then, once I find something, I will look one more place just to disprove that statement. But hopefully you're not that kind of a person, and you actually value your time. So when you find what you're looking for, you move on. What we also want to keep in mind is that with a computer is willing to do the commands over and over and over and over again. And if we're not careful about setting the condition by which we end the loop, it is possible for a loop to take infinite time. This could be just because what we're asking the computer can do is something that would be something that naturally would never end, like compute all of the decimal places of pi, or it could be through error, where we forget to change a variable in the body of the loop, which is compared every time before we decide if we should continue. So while loops take a little bit more care in crafting. Let's contrast the while loop with a for each loop. A for each loop repeats the loop body for every object in the collection, but that's not terribly flexible. A while loop doesn't have to look at every object. It can leave earlier. Now, at the top of the while loop, we will have a Boolean condition. It could be a compound Boolean with more than one condition in it. It could be a simple Boolean with just one expression. But the idea is, at the top of the loop, we ask the question. If the Boolean condition evaluates to true, we go into the body of the loop. We execute all of the statements in the loop. When we reach the end of the loop, the closing curly brace, we go back up to the top of the loop and we evaluate the condition again. Now, this is a very, very flexible approach, and an important thing is you can use a while loop anywhere, whereas a for each loop can only be used with a collection. A while loop can be used in any context where we need to repeat statements. I don't like this slide for a couple of reasons. It doesn't set up all of the things that are necessary for a while loop. When we hit the statement while, we are going to ask a question. If the condition is true, we enter the loop body, perform the loop body, reach this block, and then come back up to the while loop to ask the question again. So after you're used to using while loops, you can kind of turn it into the English statement, while we still wish to do this, do the things. I'm going to add a new slide with just a couple of blocks on it. I often think of while loops not just in the while statement, but in the one or two things that have to occur ahead of time. Set up the precondition variables. Then, while some condition is true, let me put in a rounded rectangle for this. While the condition is true, do something. And maybe we're doing a sequence of somethings. And then at some point inside of the loop, change the value of the precondition variable. So before we go into the while loop, we need to set something up that's going to be the condition by which the while loop will end. And we want to usually set it up so that the while loop goes into the process. Then the while loop's going to come through its statements, and it's going to change the value of the precondition value as part of the body of the loop. When that happens, hopefully, we come back up and we ask the question again, is the condition true? If it is, we do something, do something, do something. Hopefully, as a result, change the value of the precondition variable, come back up. Is the condition still true? It is. And then, eventually, that condition will be false. After the loop. And so, what we want to do at that point is we ask the question at the top of the loop again, is the condition true? It is not. And so this right here is when the condition goes false. And so we jump past the loop and continue with the next line after that. So you probably spent a lot of time in CSIT 103 or CSIT 105 learning how a while loop gets structured. Let's see this first in English and then back into code. So we're going to do this as pseudocode, and pseudocode is kind of Javglish, Ingva, I don't know. It's English and Java mixed together, where we're thinking of the structure that a computer requires without being tied up completely in the syntax that a computer requires. So it's a nice intermediate space for trying to think through the steps. So while the condition of the keys are missing, look in the next place. Now, what does it mean to look in the next place? That could be a very complex set of statements in and of itself. But as an abstraction, we're just going to assume that we know how to choose what that next place is. Okay, so while it's true that the keys are missing, go forward. We can also kind of reverse the logic. While the keys have been found, not. Look in the next place. Or while not the keys have been found. So the way we phrase our condition is one of two logical options. The keys are missing, I go in. The keys have not been found, I go in. This is, this will reflect itself in the way we write Booleans to determine whether or not the while condition statement is evaluated as true and that we go into the body of the loop. So to make it a little bit more Java-like, let's create a Boolean variable called searching. If searching is true, we're still looking for the keys. While true, oh, okay, true, that evaluates to true, we go in. If they are in the place, searching equals false. If they're not, we go back up and we go and look to the next place, and they're not, and we go back up and we look in the next place. Can you spot what the problem is with this algorithm? It's kind of on the slide, so it's an unfair question. What is the result if we don't find them? Try to make it a description. Even say it out loud. Given the structure of this algorithm, because we have an if statement which controls whether or not searching ever goes to false, if this never goes to if we never find them, searching never goes false, which means we're stuck in an infinite loop. Because look what happens. It's true, we go in, true, we go in, true, we go in, true, we go in. We stay here. It's only when we find them that searching goes to false. We come back up, searching is false. Oh, this while loop is now over. We jump past and we go to this area down here where a line doesn't exist yet. We could get this kind of behavior. We could make a while loop behave like a for each loop if we wanted to, but it would require more work on ourselves, more work for ourselves. So that transition was a little awkward. We've moved from looking at keys to trying to use a while loop similar to the previous example of listing all files. So the idea is a for each loop allows us to repeat code. A while loop also allows us to repeat code. We could get the exact same effect, but a while loop requires more effort to do it. So if we try to do the list all files method, we would have our pre-loop statement, index equals 0. While index is less than, ask the collection for its size, get the item from the collection and put it into a temporary string variable, and then print out the file name. At the bottom of the loop, we add 1 to index, so index was 0, it now goes to 1. Is 1 less than the size of the collection? It is. We come back in, and we get the item in the next index. So the for each loop is doing all of this for us by the nature of what a for each loop is designed to do. Here, because we're dealing with an array list, and an array list allows us to get things by index, we could implement the same thing using while loop syntax. So, in order for that to work, we had to declare a variable ahead of going into the while loop. We have to make sure that our condition is expressed correctly so that we have a way to get out. Then we have to get each element from the collection. And then at the bottom of the loop, before we come back up to the top, we need to change that index variable to move forward. Because if it never moves forward, then we will never hit the end condition and we'll be stuck in the loop forever. So comparing these two, the for each loop, much easier to write and is guaranteed to stop. But with a while loop, because we have control of the condition, it's not just have we processed everything, we can stop in the middle of the collection. We can use it outside of collections. And if we're not careful, we could create a block of code that never ends. Let's pause for a moment. Think about that. When we come back, let's look at a generic algorithm for searching using the while loop.